Okay, carrying on with some slightly more complex aspects of changing the subject of the formula. But before we do that, I want to focus on a little bit of notation. Now, this is something that causes problems even as pupils progress to higher, and it will continue to cause a problem unless we get it right at National 5. Okay, there's a couple of ways to write fractions within formula. Sometimes you'll hopefully recognize this style where we have y equals a third x, okay, and also y equals x over 3. Now, they actually mean the same thing. The trouble we have with y equals a third x is it's not always immediately obvious what happens if I decide to change the subject, okay? So if I was to start with y equals a third x like this, and then progress to another line where I had chose to flip, because we want the x on the left-hand side, then we would have a third x equals y. Okay, now the reason this is a problem is it's not always clear what the opposite of a third is. Okay, now I would always say to you the 3, sorry, is on the bottom. So at the moment, what that 3 is doing is it's dividing. So the opposite of that is multiplication. Okay, it's a little bit easier to see it that you leave the 1 where it is. It's just the 3 that's going to come up. But quite often what you see is that people try and move the third over. Okay, so recognizing that form and recognizing that we need to multiply by 3 is important. We must also recognize the second form where we have y equals x over 3. Then if we were to choose to change this and flip, okay, like we have done before, then the x over 3 equals y. This seems to be what most people find easier to recognize. Okay, so there's no reason why we can't change the y equals a third x to y equals x over 3 if that's something that you find it's easier to deal with. Okay, so here it's a little easier to see that 3 is on the bottom, so at the minute it is dividing. Okay, so when that 3 is to travel to the right hand side, the opposite operation of divide is multiply. So we're going to multiply by 3, which would then give us our 3y. Okay, 3 times y is 3y, and x equals 3y, and we will have changed our subject of our formula. Now, that may seem a little bit quick to go through that, but it's just a little bit of notation work that could make the next step a lot easier, okay? Okay, now into some of the more complex examples. We're looking to change subject of the following equation to the letter in the brackets. It just so happens that the letter in the brackets here is x. So naturally, the first thing I'm going to look at is where the letters are positioned, where the numbers are positioned, and all the letters and the numbers are on one level. There's no fractions for us to deal with here. So this means that there's a very good possibility that if we flip, it's going to make life a lot simpler. So as you can see, the x is on the right hand side, the y is on the left hand side. We want x equals at the end, so we need x on the left hand side. So the easiest thing to do is to take the equation y equals 2x plus 4 and just flip that. So we're going to have 2x plus 4 equals y. And that's the first step. We've mentioned this before. So now we've got to think, well, what is it that we don't want on the left-hand side? And there's 2 things that I would recognize that we don't want. There's the 2 in front of the x, and there's the 4. Okay, now, because the 2 is connected to the x, we would always suggest dealing with the 4 on its own. The 4 is slightly more isolated, so in that way it's easier to deal with. We've got a plus 4, a nice straightforward opposite operation. The opposite of plus 4 is subtract 4. The 4 is on the left-hand side. It's going to move to the right-hand side and become minus 4. So we're going to be left with 2x on the left-hand side, and we have y minus 4. Okay, and that 4 plus 4 is just gone to the right. The opposite operation of plus 4 is minus 4. So now the 2, we mentioned that before, that's something that we don't want. We want x on its own on the left-hand side, so we need to remove the 2. The 2, as we've seen previously, the 2 or 2x, okay, 2x is the same as 2 times x, and so the opposite operation is going to be divide. So if we have 2x on the left-hand side, 2 times x, it's going to be divide on the right-hand side. Now this is where it becomes something somewhat more difficult. We have y minus 4, and we need to divide by 2. We can't just divide the y on its own. We can't just divide the 4 on its own. We need to divide the whole thing by 2. We could put it in brackets and then write the symbol divide by 2, but at Nat 5, as we mentioned before with the fractions, we use the term over. So y minus 4 over 2 is how we would signify a divide by 2. So therefore, final answer is x equals y minus 4 over 2. Okay, example 2, changing the subject to t. And in the last example, we had the x in the brackets. This little bracket here is going to tell us that we want to change the subject of the formula to t. Okay, I'm not going to put the steps in for us. We're going to see if we can do this together now. We're going to start off, we'll just start with the actual formula. S equals 4t squared minus b. You've seen me use the therefore symbol like this. Sometimes you'll see 3 dots that also signifies therefore. It doesn't really matter which one you use. Okay, so therefore, if s equals 4t squared minus b, we've got to think, I want the t to be on the left-hand side. Is there any fractions that we need to deal with that could cause us problems? No, everything's on the one level. So step 1 to flip is going to be a lot easier in that instance. So 4t squared minus b equals s, and we've just taken the left-hand side and we've flipped it to the right-hand side. Now we've got the 4t squared minus b on the left-hand side. What we want to look at is the things that we need to remove, separate from the t. Quite clearly, it's going to be the 4 and the v, but we also have that squared term to deal with. So because the v is not connected to the t or the 4, then we can deal with that first. It's a negative v on the left-hand side. So when it moves to the right-hand side, it's simply going to change to a plus v, the opposite operation of minus v. Okay, now we've got 4t squared. Again, it's the 4 that we want to deal with. We can leave the t squared where it is. The 4t, we've already seen previously now on 2 occasions that 4t squared would be 4 times t squared. The opposite of times is divide, and how we write that at Nat 5 is over. So the whole thing, s plus v over 4. Now, one final step, and this is the first time we've seen a square term. So we mentioned it right at the beginning. The opposite of a square term is the square root. Now, it's important when we do this, if we're going to do the opposite operation, we're going to have t, we need to use the square root in the right manner. The square root must go over the entire fraction, okay? So s plus v over 4. And if it doesn't go over that entire fraction, then we could find ourselves in a bit of bother. Okay, you might see, I'll do it on the right-hand side. If we were to have something along the lines of t equals the square root of s plus v over 4, it's not as clear. It doesn't signify that we're going to use the entire fraction. Okay, we don't want to be in any way dubious about that. You want to make sure that when you're doing the square root, it covers the entire term. So that's us. We've got the t on the left-hand side. T equals the square root of s plus v over 4. Okay, we're probably getting a good grasp at the opposite side, opposite operation, and the flipping steps. Now, I want to bring your attention to some problems we have when there's fractions involved in the equation and when there's negatives. So if you have a look at this example, highlighted in red, y equals 5 minus x, right? Now, we're looking to change the subject of this formula to x. Now, the difficulty we have with this one is if we flip, as we would do normally, we've got the 5 minus x on the right-hand side. If we flip to bring the 5 minus x to the left-hand side, you'll notice that we have a negative x on the left-hand side. Okay, we're absolutely capable of dealing with a negative x on the left-hand side, but we want to make things as straightforward as we can. And if we can avoid little awkward situations like that, then it's always best to. So I'm going to show you an alternative route to solving this question. Rather than following the procedure as we have done so far and making the flip step our first step, it is possible to ignore that flip step. Well, ultimately, the reason we flip is it's the easiest route to get the x on the left-hand side. In this example, the x, it comes to the left-hand side, but it's got a negative. So you'll recognize the second way to do it, if we look at what I'm highlighting in blue, is step one, we can just ignore the flip and we can go straight to an opposite operation. And what that will do is that will allow us to move this negative x to the left-hand side. Okay, the take away x on the right-hand side would become a plus x on the right-hand side, as you can see here. Now that achieves the same thing as we would have done for the flip, in the sense that we've got the x on the left-hand side as quickly as possible. So although we've up to this point we've always been flipping, sometimes there's a way to do it without flipping. I will work through that full example to let you see what you would be doing in your jotter. So I'll go and do that now. Okay, so the layout of the working and the thinking behind this is we have y equals 5 minus x. We want the x on the left-hand side. The easiest way to get the x on the left-hand side in this instance, because it's a negative, is just to add it. So rather than flipping and allowing us to have a negative x, we just add the x. So that minus x here is going to move to the left-hand side. So we're going to have y plus x, and what it's going to leave on the right-hand side is 5. Now that just means we follow our normal processes from here. We want to keep the x on its own. That's where we want to end up with, or where we want to end up at the end, just x. And it's this y now that's going to move to the right-hand side. So that y is a positive at the moment. This is something that's worth mentioning. There's a y and there's no, in the absence of a sign, that's just a positive y. Okay, so that positive y is going to go to the right-hand side and it will join the 5 and it becomes a negative y. And that's the subject change to x only on its left-hand side, 5 minus y. No need to flip in the first instance. Okay, in a very similar way, there are times where we have a fraction on the right-hand side and the x is on the right-hand side. And you've heard me mention at this point that if the letters are all on the same level, there's no fractions to complicate things, then we can just do a straightforward flip. And you'll see here in the first example, we've got y equals 7 over x. Okay, so y equals 7 over x. And again, if we were to flip, then we would end up with 7 over x equals y, as you can see here. And the difficulty we've got there is that the x is on the bottom of a fraction. And for us to bring the x back to the top where we want it, we'd need to multiply, and therefore it would go back to the right-hand side. So if we did now decide at this point to move this x to the right-hand side, it's currently dividing. So when it moved, it would become a multiplication and it would create the formula 7 equals xy. And then we're back to the same position where the x is on the right-hand side. Now, if you did that and you followed that, you could still null flip and get rid of the y. But what I'm trying to show you is in the first instance, if you assess the question correctly and you move the x appropriately, then you can avoid the need for a flip. So if we look down at the bottom now, you can see we're still got the same question, y equals 7 over x. And instead of flipping, we're just going to use step one as the opposite operation. And that's going to bring this x up to the left-hand side, and it will create the equation xy equals 7. Okay, now that's going to look a little bit easier or clearer, sorry, when I go through it. So in the next slide, I'll go through this full example. Okay, so we're presented with y equals 7 over x. We want to change x to the subject of the formula. Normally, what I would be saying to you here is that the x is on the right-hand side, so we use step 1 and we flip to get the x on the left-hand side. However, because the x is on the bottom here, the easiest way is the bottom of a fraction. The easiest way to bring that x up to the left-hand side is to do the opposite operation, or the opposite operation of the x while it's at the bottom. While it's at the bottom, it's dividing, so the opposite of that is multiplying. So we're going to change the x y equals 7, and it's worth remembering that the reason that becomes xy is it's the same as x times y. So what we're doing is we're moving this x that's on the bottom and the right hand side, which is currently dividing, and it's moving to the left hand side and it's going to multiply. Okay, so we have xy equals 7. All we've got left to do there is remove the y. The y is currently multiplying because it's next to the x, so the opposite of multiplication is divide, and we know in that 5 we write 7 over y, which is effectively the same as 7 divided by y. And that's you done. X equals 7 over y.